Plastic is all around us. From robots, food storage containers, and water bottles, the convenience that plastic has provided our society cannot be understated. But at what cost do these advances come at? The reality is that majority of plastic will be on this planet for longer than you and I will be, maybe even forever.
A common misconception is that microplastics break down in size. They become less of a problem, out of sight, out of mind, right? No. When large plastic particles break down into smaller plastic particles, the real issue begins. Microplastics are particles of plastic smaller than less than 5 millimeters in size. When we ingest these tiny plastic particles, usually through drinking tap water or eating vegetables, which were grown from using lake water, these microplastic particles infiltrate the human gastrointestinal and circulatory systems and pose a threat to the well-being of our bodies and the aquatic creatures in our lake alike.
Doctors have already observed numerous cases of microplastics in patient hearts and even in the placentas of new mothers. This leads to hormonal disruption, clotting issues, and inflammation.
One of the most commonly used types of plastics is polyethylene terephthalate. This category of plastics is the base polymer for products such as plastic water bottles and clear food storage containers. This plastic is also most commonly irresponsibly disposed of. It ends up on our streets and in the environment, where it is left to break down into microplastics.
As the Okanagan Lake is the main water source in the Okanagan region, we decided to find out how plastics are getting into the lake and what we can do to stop them from getting in.
More specifically, we set out to find a way to minimize polyethylene terephthalate from entering the Okanagan Lake. As we began our research into this issue, we kept coming back to storm drains as the main contributor for the rising levels of plastic in the lake. Not only do storm drains carry microplastic containing rain, they also transport water from snowmelt, which carries pollutants such as microplastics from the street surfaces into the Okanagan Lake.
Our team has come up with the following novel solution to help combat this issue. This is a detailed description of our chitosan filtration system, which is designed to absorb microplastics found in stormwater. The process begins by collecting the stormwater in a steel tank, designed in a cylindrical shape for optimal stress distribution and to reduce the materials needed. Once the tank reaches full capacity, water will flow through the copper pipes into a chemical mixing tank. Then, the chitosan solution, which is derived from the shells of crabs and shrimp, is used to absorb and enlarge the microplastics. To ensure effective absorption occurs, a motor within the mixing tank stirs the water and solution together, causing the binding of microplastics and chitosan. After that, the water flows through more copper piping with the use of a pump and enters sand to filter, which is known for its remarkable retention rate of microplastics. Lastly, the water flows through an activated charcoal filter, utilizing its absorption capacity to filter microplastics from stormwater. Each design decision was made to optimize the efficiency and durability of the system.
By performing a cost-benefit analysis, we found that this solution is feasible. We also believe this system would make a great addition to the local water treatment facilities already existing in Kelowna. It's time for Kelowna to take action and implement a system which stops microplastics from entering the lake.
The implementation of our filtration system in Kelowna represents a vital step forward in safeguarding public health.
And also fostering a community committed to ensuring clean and safe drinking water for generations to come.